Okay, today we're talking about chapter 3.3, which is about comparing and ordering decimals. Okay, our learning goal today is to be able to compare and put decimals in order up to the thousandths using place value. Okay, our problem of the day, did that use a lot of skills that we might need to use when we compare decimals as well? Yeah, so I put this as the problem of the day. I made up this problem because I wanted us to think about what we need to do when we compare whole numbers, when we determine which whole number is greater than another whole number. Because, as it turns out, those are the same skills we'll need to compare and order decimals. Okay? All right, let's take a look. It says this table lists some of the mountains in the United States that are over 2 miles high. Okay, they're more than 2 miles tall, these mountains. How does the height of Cloud Peak in Wyoming compare to the height of Boundary Peak in Nevada? Oh, it's a word problem. What's the first thing I need to do when I'm faced with a story or word problem? Daniel? Yeah, we need to find out what the question is asking. And what is the question asking in this case, Daniel? It's asking me to compare the heights of Cloud Peak compared to the height of Boundary Peak. Very good. What's step 2, Claire? What do I need to do next? What is the important information? It's not quite 2,495. I know it looks like it, but it's a decimal point. So it's 2 and, yes, 2 and 495 thousandths miles high. Very good. And is there any other important information we need? Awesome. Okay. So we know our two numbers that we need to compare. So in order to compare these two numbers, just like we had to line up all the place values when we were comparing those YouTube views, right, for Anna and Jake, we need to line up each place value here. The best way to do that is to line up the decimal points. So let's first write the height of Boundary Peak, which is 2 and 488 thousandths miles. And we can label that BP for Boundary Peak. Right? Then we also have Cloud Peak, CP, which is 2 and 495 thousandths. Are the decimal points lined up? Let's take a look. Are they lined up? Are all the other place values lined up? Is the ones place lined up? Is the tenths place lined up? Is the hundredths place lined up? Is the thousandths place lined up? Very good. Now we're ready to compare. Step 2, it says starting from the left, compare the digits until they are different. Let's look at what's my digit, what place value do I have on the very left? What place is that? Is it the thousandths, millions, tenths? What is that? What place is that, Ashi? The ones. Are my numbers the same in the ones? Okay, let's move one to the right then. Next, let's look at the tenths. Are the numbers the same? That doesn't help us. Let's move one over to the right one more time and to the hundredths. Are those the same or different? Okay, so now are we able to use that to compare the two heights? Which mountain is taller? Which mountain is taller? Neha? Yeah, so we can say that 2 and 495 thousandths is greater than 2 and 488 thousandths. And therefore, Cloud Peak is taller than Boundary Peak. If we don't like just lining up the decimal points, we can also organize everything in a place value chart. This time it's asking us to compare the height of Cloud Peak to Wheeler Peak. Okay, so here's Cloud Peak, and here's Wheeler Peak. Go ahead and give yourself a quick place value chart and write the heights of Cloud Peak and Wheeler Peak into the chart. What's my ones for Cloud Peak? What digit do I have in the ones place for Cloud Peak? Adam?
The digit in the ones for Cloud Peak is 2.
Is 2. What digit is in the tenths place for Cloud Peak, Zara? 4. What about the hundredths, Soham?
9.
9. And what number do I have in the thousandths place for Cloud Peak? Misaki? 5. Okay. Now let's talk about Wheeler Peak. What digit do I have in the ones place, Adriana? Okay. What do I have in the tenths place, Clarissa?
4.
4. What do I have in the hundredths place, Stevena?
9.
And finally, what do I have in the thousandths place, Stuart? 3. Okay. Now everything's in the correct place. The place value chart really just helps us make sure we're lining up all of the place values, right? Now I'm going to start comparing. Oh, 5 is bigger than 3. 5 is greater than 3. I see that here. So I know that this top one, Cloud Peak, must be greater than Wheeler Peak. Huh? Yeah, I mean, what's going on? Why is everyone looking so confused at me?
True, but you're like, so what if the 2 over there is like a 1?
Did I make a mistake? In my
Yes.
did it?
Yes.
My answer you're saying my answer is correct, but I made a mistake?
Yes, you have to go from left to right.
Oh, I have to start comparing from the left to the right. Why is that?
Because the right is greater.
The what is greater?
I mean the left.
The left place values are greater. So I need to actually start comparing from the left to the right. Now in this case, did it happen that all the other digits are the same?
Yes.
So I lucked out, right? That's called a lucky mistake. But we know that we need to start comparing from the left to the right. But we still know that Cloud Peak is still taller than Wheeler Peak, right? Here's a good question for you. Why is it important to make sure we line up the decimal points and line up the place values when we are comparing two numbers? Why is that important? Soham?
So that we get our answer the correct place value.
But why does lining up our decimal points and lining up our place values, how does that help us make sure that our answer is correct? You are right that if we don't do that, we might get a wrong answer. But how does lining up the decimal points and place values help us make sure we get the correct answer? Clarissa?
Like if you mix up like which numbers it is, like the place value. So like with additions or multiplication, sometimes if my numbers sort of look diagonal, sometimes I mix it up.
How many of you guys, it's really important to line up the decimal points because that helps us make sure all of our place values are in the right order, or they're lined up, and we're comparing the correct numbers. In this case, if I were to mix it up and write 2.495 and 2.493, might I say, oh, 4 is bigger than 2, and compare it like that? Would that be a fair comparison? No. Would that help me be accurate in my math? No.
But you'll make a lucky mistake.
I would get lucky again this time, huh? But is that being precise? Is that attending to precision and being a good mathematician? No.